Okay, so we got through questions 1 and 2 yesterday, so we are ready to look at question number 3. Let's look first at the solution. So question number 3, this is an observational study because there were no treatments imposed. The model of CAR was not randomly assigned to the subjects. Instead, the model was simply observed by the researcher. Part B, number the days 1 to 70. Use a random number generator to select 35 unique numbers between 1 and 70, no repeats. Use the autopilot feature for the days that correspond to the selected numbers. Don't use the autopilot feature for the remaining 35 days. And then part C, James would need to use a random sample of Model D cars in his club for his experiment. The random sample should be representative of all Model D cars and would allow him to generalize his results to all Model D cars in his club. So now let's look at the rubric. Has everybody found question 3 in your packet? Have you found question 3 in the scoring guidelines yet? Wonderful. All right, so let's look at those scoring guidelines for question number 3. 3 components for part A. They need to identify this as an observational study. So the first thing you're looking for is that word. 2, provide justification based on no treatment being imposed. So they're only watching, or the cars or participants were not assigned to do anything. Somewhere in there, we need to address the fact that no treatment was imposed. Thank you so much. And then they need to include context. So they need to talk about James and Model D cars and whatnot. If they have all 3 of those components, then please give them an E. If they have 2 of those components, then please give them a P. And if they don't have any of those components, then please give them an I. Each car model. Personally, I would say yes, because they're referring to cars there. It's an observational study because there's no control group. Unfortunately, because they didn't get context in that. If they'd said something about cars, or Model D cars or something like that, then they would get context. Right. Does anybody else have any questions about part A? About scoring part A? All right, part B. We're looking for 3 components here. Creating appropriate labels for the units and the treatments. So this, in the model solution that we looked at, this is where they said number from 1 to 70. Describes how to correctly implement the random process so that every possible random assignment is equally likely. A random number generator is a really good way to do this. The response indicates a random process that results in 35 days assigned to using autopilot and 35 days assigned to not using autopilot. So they literally have to say in their response that the 35 chosen numbers or the 35 whatever are going to use the autopilot feature, and then they have to mention the other 35 will not use the autopilot feature. If they do not assign both groups of 35 to a treatment, they do not get that 3rd component. Make sure that they have some way of labeling the experimental units and talking about that random process. There was another way that I have seen other than a random number generator that could be used. If you look at this solution here, they're talking about 35 slips of paper that say with autopilot and 35 slips of paper that say without autopilot. And then it would be put into a bucket, a hat, a container. You have to talk about it being random, so you have to talk about it being mixed up if you're going to talk about those slips of paper. Yes? I would say that they generate 35 unique random numbers. I think that would be okay because they used random back there. Yeah. Is flipping a coin okay? Would that be guaranteed to result in 35 in each group? Then unfortunately it would not. Because if you flip a coin, every individual, every piece of the experimental unit, every individual subject would have a 50-50 chance of which group they were in. But if I flipped 38 heads and those went in my autopilot group, then I wouldn't have 35 for my other group. So flipping a coin is a great random process, but it doesn't always work because it doesn't always guarantee an equal number in each of the two groups.
So even if they have like context, it'll still be wrong because they flipped the coin?
So if they talked about labeling the units and they described using a random process, they could still get a P but not an E. Flipping a coin would be a random process, but it doesn't meet the third component that says it results in 35 days assigned to using autopilot and 35 days assigned to not using autopilot. So it is a random process, and you would get credit for it being a random process, but you would not get credit for being able to guarantee 35 in each of those groups. Does that make sense? Okay. All right, does anybody have any other questions on grading part B? Right. Good grief. And part C, we're looking for 3 components. The response indicates that more cars must be sampled. The response indicates that random sampling is required for generalization. So they have to talk about random sampling, and they have to talk about that's what allows you to generalize to the population. And the response is in context, which would include sampling from the population of interest. So got to talk about Model D cars from his club in some way or somehow, because the population is this Model D car club. So if they get all 3 of those components, then please give them an E. If they get 2 of those components, please give them a P. And if they got 1 or none of those components, please give an I. Yes.
Apparently
They have random. Response indicates that more cars must be sampled. Randomly choose a car from the club each day to drive to and from work for that day. Oh, I'm on the fence about that one. I would probably give that. It's very close to an E. I would say you need to put some kind of, like, for the next 100 days, he would select 100 new cars randomly or something like that. Probably heads can be auto and tails can be manual. Heads is split so that there is auto and tails is manual. On the 3rd day, the coins will begin and so on. Random. All right. Now to score, this needs to be up at the top of the question. You need to give a 1, 2, 3, or 4. If they got all 3 parts essentially correct, then they get a 4. If they got 2 parts essentially correct and 1 part partially correct, so 2 E's and a P, then they get a 3. There are several ways to get a 2. 2 E's and an I. 1 E and 2 P's, 1 E and 1 P and 1 I, or 3 P's. Those are all ways to get a 2. And to get a 1, you have no E's and no P's. Oh, sorry, one E and no P's. I misread that. One E and no P's, or no E's and two P's. So two P's and an I, or one E and two I's would be a 1. Yes. IIP, that would be a 0, unfortunately. All right, you guys ready for the next one? All right, question number 4. Let's look at the solution, and then we'll look at the rubric. This is Conrad and the red crystals. This was the probability question. There will be a probability and sampling distribution question somewhere in the free response questions. We'll look before the day of the exam at, like, what are the 6 questions you can expect? What types of questions will they be, so that you can go in prepared for that. But there will always be one about probability and sampling distributions. So number 4, part A, I, the mean is 1 over P, 1 over 0.08, so 12.5 geodes. The standard deviation is the square root of 1 minus P over P. You do have these formulas on the formula sheet, and I'm happy to show you guys where those formulas are. Part B, I, probability that y equals 3 would be 0.92 squared times 0.08. We end up with 0.067712. You do not have to take it out that many places, but I would take it out to at least 3 or 4 decimals there. Part II, the probability that y equals 4 is 1 minus the other 3 probabilities added together, because you only go up to 4. It's 4. I'm trying to remember the way the question is actually worded there. But the idea is that it stops at 4. It does not keep going until success. It's until success or the 4th one. And so that comes out to be 0.778688. Part CI, the mean, this is the expected value, 1 times 0.08 plus 2 times 0.0736 plus 3 times 0.067712 plus 4 times 0.778688. Gives us a mean of 3.545 geodes. I'm not reading all of those decimals. CII, if Conrad were to repeat the process of selecting the geodes until he gets a red crystal or gets to 4 geodes, many, many times, the average number of geodes he would select is 3.54 in the long run. You guys ready to look at the rubric? Does anybody, before I pull the rubric up, does anybody want to see the formula sheet for this stuff so that you know where to find it? Okay, I'll make sure to pull that up too. Let's grade this and then I'll pull up the formula sheet. So question number 3. 4 components. In part AI, the response correctly calculates the mean. So they come up with 12.5 geodes. In part AI, the response provides supporting work for the calculation of the correct mean. So they have to show their work, and they have to come up with the correct calculation for the mean. That's these first 2 components. The second 2 components, the response correctly calculates the standard deviation, and the response provides supporting work for the calculation of the correct standard deviation. So we got 11.99 for the standard deviation here with work shown. If they got all 4 components, then they can get an E. If they satisfy 2 of the 4 components, then they can get a P. Otherwise, it's an I. So all 4 components is an E. 2 of the components would be a P, and none of the components would be an I. All right, let's pull up this formula sheet so that I can show you guys exactly where this is. Sorry, it takes me a while to get there. I wish I could just hop right to the formula sheet, but they make me jump through all these hoops to get there. All right, reference sheet right here. We're not going to the tables. We want probabilities and distributions. This is where you're going to find stuff like this. Probabilities and distributions. We've talked about those first two pieces. We used those on some free response questions, but then we come down here to where it says probability distribution. If X has a binomial distribution with parameters n and p, then the probability that X is equal to some value is n over X. Remember, that's NCR. That's the way. Do you guys remember how to get there on the calculator for the combination stuff? I will happily show you as we get closer to, but you get there with the math button and then you arrow over to probability. And then the probability of the desired outcome to the power of how many times we want that to occur, times 1 minus the probability of the desired outcome to the power of whatever remains in n. Because x and n minus x should always add up to n. Here's the mean for binomial distributions, n times p. And here's the standard deviation, square root of n times p times 1 minus p. For geometric, this is the one that we're looking at here with the geodes. The mean is 1 over p, 1 over the probability, and the standard deviation is the square root of 1 minus p over p. Do you guys remember the difference between binomial and geometric? Because they're very similar. What is the main difference? Yes, geometric, we go until we see our first success. We will only ever have one success, and it will be the first success. Binomial, we need a set number of trials, but the number of successes we decide on. We want 5 baskets, we want 10 baskets, we want 50 baskets, we want however many successes out of a certain number of trials. And binomial and geometric, there's only 2 possible outcomes. There's a success and a failure. Success would be your p, failure would be n minus p. Are you guys good on part A? Yes. Are you good on part A? Part B then. Oh, come on. Sometimes this works well and sometimes it doesn't. Go away. Thank you. All right. In part B, once again, we have 4 components. In part BI, the response correctly calculates the probability of opening 3 geodes. This is how they calculated the probability of opening 3 geodes. In part BI, the response provides supporting work for the calculation of the correct probability. So showing the work is component 2, correct probability is component 1. And then in part BII, the response correctly calculates the probability of opening 4 geodes consistent with the response to part BI, and it provides supporting work. So there are 2 ways that you can go about calculating this. This is showing one method. This is showing another method. They both result in the same probabilities. If they get all 4 of those components, please give an E. If they get 2 of those components, please give a P. And if they got none of the components, please give an I. And then the last part of the question, CI. We have 5 components here. If the response satisfies both components 1 and 2, and at least 2 of 3, 4, and 5. So we need both of these and 2 of these 3 to get an E. So in part CI, the response states the correct mean of the distribution consistent with values calculated in part B. In part CI, the response shows appropriate work to calculate the mean using the values calculated in part B. So if they got part B wrong, but they used the numbers correctly here in part C, they plug them in the right spots, and they show work, they can still get components 1 and 2. And then for CII, that's these bottom 3 components, they need 2 of the following 3. The interpretation includes the concept of repeating the selection process over a long period of time. So they say if we do this many, many, many times, or they talk about in the long run. In part CII, the interpretation includes the concept of an average or a mean. So they really should be using one of those 2 words, average or mean. And in part CII, the interpretation includes the context of number of geodes opened. So 2 of those 3 components, and both of these components to get an E. To get a P, you need 2 or 3 of components 1 through 4. 2 or 3 of these would get a P. And anything other than that would receive an I. If you have not already, please give them an E, P, or I there. And then we're going to give them a score of 1, 2, 3, or 4. When we are grading in 3 sections, the scoring stays consistent. So 3 E's is a 4, 2 E's and a P is a 3, 2 E's and an I, 1 E and 2 P's, 1 E and 1 P and 1 I, or 3 P's is a 2, 1 E and 2 I's, or 2 P's and an I would be a 1. And if they did not meet any of these criteria, then it would be a 0. All right? So far, so good. Wonderful. We've got 2 questions left to go. My hope is that by tomorrow I can have what your score would be if this had been the actual exam. It might not be until Thursday. It just depends on how long it takes me to get the information off of all of the tests. All right? Question number 5. Question number 5, part A, 71 plus 76 plus 112 over 500 gives us 0.518. Part B, 80 over 91 equals 0.879. Part C, chi-square test for independence. CII, there is no association between the number of months spent collecting baseball cards and which type of card has the majority in the collection, regular or rare. The HA is there is an association between the number of months spent collecting baseball cards and which type of card is the majority in the collection, regular or rare. And then part D, because 0.0075 is less than 0.05, Michelle will reject the null and does have convincing evidence of an association between the number of months spent collecting baseball cards and which type of card is the majority in the collection, regular or rare. So scoring for question 5. Part A, 2 components, provides the correct probability, shows work for the correct probability. So they need to arrive at 0.518. If they left their answer in decimal form, in fraction form, but it is the correct fraction, then they could still receive full credit. It did not say it had to be in decimal form. So showing their work and providing the correct fraction or the correct decimal. E would be both components. If they only get one of the components, then they get a P. None of the components would be an I. Are you ready for part B? Part B, 2 components here also, provides the correct work and provides the correct probability. So we have the majority of regular cards given fewer than 6 months. You'd have the intersection here over fewer than 6 months. They do not need to have the text, but they do need to have the work. 80 over 91 which would give us 0.879. If you guys want me to go back to show you the work that was on that model solution so you can see what adequate work would look like here, I'm more than happy to flip back to that. So both components, they get an E. Only one component, they get a P. And no components, they get an I. You guys ready to move on? Please let me know if you're struggling to score these at all. This is going to be very important feedback for your classmates. Three components here in part C. In part CI, the response identifies a chi-square test for independence by name. You can also call it a chi-square test for association. That would be another name that is fine to use here. Component 2, in part CII, the response states the correct null hypothesis to imply that there is not an association, not a relationship, and states the correct alternative hypothesis to imply there is an association, there is a relationship. So if they said in the HO that these are independent and in the HA that they are not independent, that would be okay as well. Independent would give the idea that there's no relationship, no association, and dependent conveys the idea that there is a relationship, there is an association. And then in part CII, for component 3, the response provides sufficient context for at least one of the hypotheses by including reference to both months collecting and majority card status. So in either the HO or the HA, or in both, they have to talk about the months collecting and the majority card status, so rare or, I don't remember what the other one was. Rare or common, rare or something. I don't remember the language there. If the response has all three of those components, then they get an E. If they get two of those components, then they get a P. And if they got one or none of those components, then they get an I. Yes. You need some help grading yours also. Not a problem. I'll be right there. Oh, there is a relationship. There's not a relationship. Do they have context? And do they talk about chi-square? Okay. Unfortunately, that's going to be an I. Switching the HO and the HA there. If we had identified the correct test with what they have, that would have been a P, but because of the incorrect test name, it's going to be an I. Okay, so they would not get credit. That would be an I on this part. Yes. Yes. And I'll finish grading this one. Yep. I'll do. Oh, you said the last two were totally blank. Oh, even easier. All right. You're all done with yours. All right, and then we had a part D on this one, looking for two components here. Provides correct comparison of the p-value to the alpha value, saying that p is less than alpha, and provides a correct decision about the null and or alternative hypothesis. So p is less than alpha, giving the actual values, showing that inequality, and then saying we would reject the null hypothesis. And component 2 states a conclusion in context, consistent with and in terms of the stated alternative hypothesis in part C using non-definitive language. So here's another example of what this could look like other than the model solution that I showed you, because the p-value of 0.0075 is less than any reasonable alpha levels such as 0.05 or 0.10. The null hypothesis should be rejected. The data provide convincing statistical evidence. This is that conclusion part right here. Provides convincing statistical evidence that there is an association between months collecting baseball cards and majority card status for all baseball card collectors at the convention. If they got both of those components, then they get an E. One of those two components, they get a P. None of the components would be an I.
Say what you should do with the hypothesis should they not get the fish print.
There is an association. opening cards. A variety of card in the collection. After equals 0.01 level. I would say right here they said there is an association. So here if they say, you know, they conclude that there is an association, that would be in terms of the ha. They didn't refer to ho and ha necessarily, like reject the ho, fail to reject the ho, but they did state there what the correct decision would be, which would be to conclude that there was an association. Oh, thank you. All right. This is the first question that we've had that has 4 parts to it, so the scoring is a little bit different. Yes. Oh, you had a question about this, yes.
Because they put regular or rare, does that make it wrong? Because it's not anything with 2 samples.
Majority in the collection. What are they missing?
Yes. Okay.
Okay, so we have a decision. We have comparison to alpha.
Mm-hmm.
Yeah, it looks like they're missing component 2.
So it would be P.
I would give a P. Yep. Yes. Yes. All right, let's look at scoring for this question. And then we will grade the very last question in the packet and finish it off. All right, scoring. So for this one, we're literally just going to count up E's, P's, and I's. And E counts as 1, a P counts as a half. So it's possible that when you count up the E's, P's, and I's, you're going to end up with like 2.5. If that happens, we're going to have to choose to either round up or round down. There's no half points on scoring these. So an E is worth 1, a P is worth a half. If theirs comes out to be a whole number, just using that, write down that whole number, that's their score. If they're on the border, if they got a half, you have to decide whether to round up or round down based on the quality of their answer. So how well did they express their ideas? How, like, did they get a P just because one little tiny piece on a section and that's why they have that half point, but other than that, they hit everything that they were supposed to? Or is their answer like a solid P on that section and so we should round it down? When they say to use a holistic approach there, we're looking for if the quality of the answer overall was high, but they missed one little thing and that's why they got a P on a section, then we would choose to round up. If the quality of the response was just normal or possibly low, then you would round down. Does anybody have any questions about that one? All right, last one, and then we will be done with this. Question number 6, let's look at the model solution first, and then we will score it. Part A, 1 sample T interval for mu. That's for part AI. AII, the true mean price in dollars of this type of whistle at all stores that sell the whistle. Part BI, the shape of the distribution of the sample of whistle prices is skewed right because the mean, 5.12, is greater than the median, 4.885. Part BII, Q1 minus 1.5 times IQR would be 4.51 minus 1.5 times, and then they're showing Q1 minus Q3. We get 3.0625. There are no low outliers because the minimum, 4.25, is bigger than the threshold for an outlier. Q3 is 1.5 times the IQR, so they show that work here. We get 6.9225. There are no high outliers because the maximum, 6.58, is smaller than the threshold for a large outlier. And then part CI, show the work for Pearson's coefficient of skewness. Part CII, this right here, that X. Part D, The shape of the distribution of the sample of whistle prices is strongly skewed right. It is strongly skewed because a coefficient of 0.949 with a sample size of 20 lands in this region of the graph in C. It is skewed right because the Pearson's coefficient is positive. So it is strongly skewed if the coefficient lands out here. And it is strongly skewed to the right because we have a positive coefficient for Pearson's coefficient. And part DII, no, the normality condition is not satisfied for Julio's data because the sample size of 20 is less than 30. And while there are no outliers, the distribution is strongly skewed according to the Pearson coefficient. So if, when you got to this question, you were thinking, I have no idea what a Pearson's coefficient is, that's normal. It's not covered in the AP Statistics curriculum. The 6th question on the AP exam will always push beyond the scope in this course, but they will give you some kind of like guidelines to follow so that if you understand the statistical concepts covered in the course, you should be able to walk through and basically learn a new thing while you're taking this test. All right, so let's look at the scoring guidelines. 3 components for number 6, part A. In part AI, the response identifies a 1 sample T interval for a population mean by name. So a 1 sample T interval, or a 1 sample T interval for mu. In part AII, the response identifies the correct parameter by including reference to the mean. The response provides sufficient context for the parameter by including reference to the population, all stores that sell the whistle, and the variable of interest, the price of this type of whistle. So we need to talk about the parameter of interest being the mean, and it needs to talk about all stores that sell the whistle and the price of the whistle. If they get all 3 components, then it's an E. 1 or 2 of the components would be a P this time. If they get 1 or 2 of the components, then it would be a P.
It says T-test instead of integral.
That unfortunately would knock it down.
So,
Yep.
actually,
If they got the other components, then yes, it would be a P. Thank you. Did you need to use the restroom? Did you need to use the bathroom? Okay. All right, does anybody else need help scoring this section before we go on and look at B? Part B. There were 4 components here. In part BI, the response indicates the distribution is skewed to the right, or they can say approximately symmetric. With the mean and the median that close together, you could also get away with approximately symmetric. So either skewed right or approximately symmetric in part BI. In part BI, the response justifies the response to component 1 with appropriate reasoning based on the summary statistics. So they have to give some reason for why they're saying skewed right or approximately symmetric. In part BII, the response provides a justification for stating that there are no outliers by correctly calculating the lower and upper outlier criteria with work shown. And then component 4 in part BII, the response states whether there are outliers based on the calculated lower and upper outlier criteria. So in part BII, they had to calculate both of the boundary lines for the outliers, and then they had to state that there were no large outliers and there were no low outliers, or they could say there are no outliers if they've shown those 2 boundary lines. If they satisfy 3 of these 4 components, then they get a P. Less than 3 of the 4 components would be an I. So 1 or 2 components, or none, would be an I. Does anybody have any questions over how to score this part? Okay. Part C. Two components here in part CI. The response calculates Pearson's coefficient of skewness with work shown. So something like this. In part C, II, the response includes an X at approximately 0.949 and 20, or an X consistent with the calculation in part CI. So if they calculated this part incorrectly, but they put an X on their version of the graph, and I know this is going to be a little bit hard because you had to kind of sketch the graph in yourself. So you're looking for an approximate location here. If they got both of those components, then it's an E. One of the two components is a P, and none of the components would be an I. And I will tell you for future reference, with the exam coming up next Thursday, if you are expected to draw on a graph like here, that graph will be provided for you in the answer booklet. So you will not have to hand draw any graphs. Also, from what I understand, there will not be anything like that this year. That's what I've been told. Now, please don't get mad at me. I'm just telling you the best of my information, but I've been told that the sample booklet that I was provided with is exactly what your booklet will look like this year. But I've also been told that if you're expected to mark on a graph, the graph will be provided for you. All right, last part, part D. Five components here. In part DI, the response indicates the sample is strongly skewed or makes a statement that is consistent with the graph in part C. So if they incorrectly calculated Pearson's coefficient, and so their X was in the wrong spot, but it's in the right spot for the work that they calculated, they need an answer here that goes with where they put their X. In part DI, the response uses or refers to the graph or the Pearson's coefficient of skewness to make the correct determination of skewness. In part DII, the response states that the condition of normality is not met or makes a statement consistent with the explanation in part DI. In part DII, the response explains the sample size of 20 is less than 30. So you've got to talk about that central limit theorem idea there. And in part DII, the response explains that the distribution of sample data is strongly skewed or makes a statement consistent with the explanation in part DI. All five of those criteria would be an E, 3 or 4 would be a P, and 2 or less would be an I. Please go ahead and score this part. And then the scoring for this one, the 1, 2, 3, or 4, is done the same way that question number 5 was. Every E is worth 1 point. Every P is worth ½ point. If you end up with like 2½ points, you're going to have to round up or round down, make a decision to go up or down to either a 2 or a 3. Give them a whole number. When you are finished grading that, please come place the mock exams on desk 3. And the booklets next to the pens, please. Starting tomorrow, we're going to be doing some more practice FRQs. We will be doing the free response question. We're going to work our way through the 2023 exam. We're going to look at all 6 questions there. We'll look at a question. You'll have time to answer it. Then we'll score it. Then we'll do another question. You'll have time to work on that question. Then we'll look at the rubric and we'll score it. We're going to do that for all 6 questions. I'm anticipating that this is going to take us 2 days to get through the 2023 exam. But if it ends up taking us through Friday, that's okay. All right? All right.